Leave it to math teachers to make something like 2, 4, 6, 8 into something really complicated. So let me explain. This 2, then 4, then 6, then 8, dot, 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 is a sequence. All right? And it obviously starts with something. Now, could you start the even numbers somewhere besides 2? Yeah, you could start it at 22. And you go 22, 24, 26, 28. So to tell a sequence, you have to tell two things. You have to tell where you want to start it, and you have to tell what to do to get to the next number. Because is it always going up by 2? Of course not. Sometimes it could start with 7 and go up by 3, and then it'd be 10, and then it'd be 13, and then it'd be keep going like that. Okay, so you got to tell me where to start and then how much to go up by. Now, could there also be a sequence where I start with like 6, but I times by 3, and that makes 18? But as soon as I write two numbers, I can't automatically know what just happened. All I know for sure is that I started with 6 and I went to 18, and it could have been that I times by 3, but it also could have been that I added, let me think, 12. Yeah, it could be add 12, or it could be times by 3, but you can't tell. That's why we pretty much always give you 3 numbers in a sequence. We don't just give you 2, because you can't tell if we added or multiplied. All right, so if I give you the third number, and I go, I actually did times by 3, so then that would be 10 times 3 is 30, 8 times 3 is 24, 30 and 24 makes 54. I don't know if you saw me doing that in my head there. Now you can tell for sure I didn't add 12. I must have times by 3. All right, so now there's some common, there's some words that we're going to have to use over these next few days that you'll have to get used to, and you'll have to pull out of your head. Like, we have some formulas we give you, but there's some words you will have to know. One of them is that when you multiply by something, it's called geometric. So please, let's start with actually this one and write 7, 10, 13 and write arithmetic. It's spelled like arithmetic, but you pronounce it arithmetic. I know that's weird, but it's true. This is an arithmetic sequence. Whereas on an arithmetic, you're just adding. And could you add a negative number and make it like subtracting? Yeah. So you can either add something or subtract something. But I just think of that as adding or adding a negative. This kind is called geometric. And that means basically that you're multiplying. I don't know why they didn't call it multimetric. You know, they had arithmetic. Multimetric would have been a cool name, but they went with geometric. All right. And you have to tell me where to start. And even if you tell me it's geometric and I know what you multiplied, you have to tell me what you multiplied by. Now, if I just saw these numbers, I could in my head go, oh, 6 times 3 is 18. It must have been times 3. But there's a way to do it where you take this number divided by that number. I'm going to write 18 divided by 6, and that'll tell you what they did. Do you get 18 divided by 6 is 3? And so that can tell you, oh, that's how you can always get it. You take the second number divided by the first number, and that's called 3, and that's called, please write this down underneath the geometric one, common ratio. That's one of those words you'll have to know on the test. That's called the common ratio. Now, common is because it's in common every single time. Like you're going to times by 3 every single time. And ratio, it's because there's a top number divided by the bottom number. This is called a ratio. Divides are just basically the same as a ratio. Yes? Could you say that again? Yes. You show me a pass that in from the hub, that works. And I'll say yes. All right. So that's a common ratio. Back to this kind. Would I want to do 10 divided by 7? No, because that's not what happened. I could do 10 minus 7, though. And that's called the common not ratio. Cool. Wait, actually, I don't see a pass there yet. Make sure it says yes. Okay, good. Common difference. There's a lot of little terms for these things. That's the difference between the two numbers. And it's in common because it's the same every single time. All right. So, let's see if you've processed what I've been telling you. Are you picking up what I've been laying down? If I start with 5, I got to tell you what to start with. And then I do this. Is this kind the arithmetic, sorry, I can't even say it myself, arithmetic kind, or is this a geometric kind? Just say it if you know. It's arithmetic. This is an A. You'll have 2 choices. It's either arithmetic or geometric. Okay, this one's arithmetic. Starting number was 5, and the thing we do each time, you could technically take 10 divided by 5. That's why we call it, starts with an R, ratio. And what is that common ratio? It is, 10 divided by 5 is absolutely 2, and I just did that wrong. Dang it. That is not what I should have done. That's if it was geometric. This isn't geometric. What is this kind? Arithmetic. And so this is the kind where you add or subtract. And you could probably do this in your head faster than writing it. But I could go 10 minus 5 because it's called the common difference. And what is the difference? 5. Because see, if you go 5, 5, and the next one you need to add 5 more. The common difference is 5 for this arithmetic sequence. All right, so we got some common language we can use now about sequences. Made it much more complicated, but there's names for these things. Makes some sense. The starting term, the common difference each time. All right, so what if I started with 2? I times by 2 is 4, but you couldn't tell if I added or times, but I told you it was times. So 4 times 2 is 8, ... So I used a bunch of terms. This is either arithmetic or geometric, and it has either a common difference or a common ratio. Would you please write down the 2 answers that you know? It's either arithmetic or geometric. Hopefully you can pick the right one. And it's either got a common difference or a common ratio. And what is that? So for today, we're just taking the little sequences that you've seen these before, and you've probably been able to like predict what the next number is. That part's pretty easy, but the terminology is new for you, and this next part is really going to be new. And that's how to write them in a recursive sequence. So why do we have to do this? This honestly is one of those things where it's a type of formula that the state of Minnesota wants you to know. A bunch of really smart math teachers get together and decide what should be the most important skills. So we could teach you thousands of things about math, and they pick the ones that I think are the most important, and this is one of those. This is one of the standards of math. You have to know how to do a recursively defined sequence. It sounds really complicated, but it's just taking a sequence like this and making a math formula for it. So I'm going to teach you that. The ACT has these. The MCAs, which is the state tests, have these. Someday when you go to college, you'll have to take an entrance test, like which math class should we put you in? It'll be on there. It's one of those like, really important math things. All right, so this one, I hope you knew that because I was multiplying each time, it was geometric, and it had a common ratio, because you take this divided by that to see what you multiply by each time. 4 divided by 2, which was 2. And the reason it's common is because you could do this divided by this, and you'd get the same thing. 8 divided by 4 is also 2. So 2 was the common ratio. You with me so far? Okay, there's just some terminology. Now here's the part that's going to maybe, like, it's one of these things where it's hard to understand but easy to do. I'll show you. Let's say we've had a sequence going for a long time, and we got to 110, and then we went to 115. Would you suspect that we were adding 5 each time? That's probably the logical thing. Is there some weird number we could have multiplied by to get that to happen? Yeah. You could theoretically take 115 divided by 110 and it would give you this weird decimal you could multiply by each time. But instead, we probably just did 115 minus 110, which is 5, and that's called the common difference. Now, you can't tell unless we tell you. What if I told you that the sequence was geometric? Then I just told you which way you'd have to do it. I'm going to say, this one's geometric. And what do you know? Well, you know the other thing. You can tell then whether I added or multiplied. And if I multiplied, you can tell what I multiplied by. Take a second, figure out. Since this one is geometric, then it must have a common blah. Chi, common what? Common ratio. Good. And what is the ratio?
1.04545.
Awesome. And I think you probably did that by dividing 115 divided by 110, right? Awesome. 1 point, can you tell me that again?
1.04545.
And it keeps on repeating. All right, cool. And on our project, I never told you where to round, and so I accepted wherever you wanted to round. On a test, we'd have to tell you where to round to. Otherwise, you just keep writing it for a bunch of times, and eventually we'll get the pattern, right? Technically, you could put a line over those two numbers, and that assumes it keeps going like that forever. All right, cool. Okay, so back to the last thing I have to teach you before we're done. And I get to just have you practice a few problems, and yay, we're back to kind of normal life again here. Let's say that I wanted to just keep going with this, but it was adding. Then it isn't geometric, it's what? Arithmetic. And the next number would actually be 120, because I'm just adding 5 each time. Because it's got a common difference of 5. All right. So here's the part that I said was weird. Hard to understand, but easy to do. This is a term, and we call it U sub something. Sub as in subscript. This could be, I don't know where we started. Like, we could have started with, I don't know, 10. We could have started with 5. We could have started with 0. We could have started with -5. I have no idea where we started. So this could be U sub 25. I don't know. Could be U sub 30. It could be U sub n. I don't know which term it is because I don't know where it started. But if this is U sub 25, then this would be U sub 26. And the one in front of it would have been U sub 24. Do you get that they would go in order like that? And a sub number, a subscript, can tell you which one you're on. All right. So again, I didn't know for sure which one it was. It could have been that we were on the 10th term right here. And then this would have to be the 9th, and this would have to be the 11th. Do you get how we're going to number the terms? Okay. But I haven't been told what the first term was. That's why the first term is so important, because then you can tell, oh, then this term must be like the 12th term. All right. So here's the last weird part. What if I don't know which term it is, but I still want to give it a name? Not like Bob, but like U sub something. But I can't just make up a number because I don't know which one it is. What do you think? What should I put there? U sub what? Yes?
Because we're adding by 5, if you do 115 divided by 5, whatever that number is the
That's a good guess, but you're assuming we started at 5 by that. And we don't know for sure we started at 5. We might start at 0. We might start at -10. So that was a good guess. All right, so if I don't know what term to start it at, I'm going to say U sub n. N is a variable, and if you don't know what number to put, you put a variable. So please, if you haven't been taking notes for a while, it's okay, but right now, write this down. U10, 110, 115, 120, and this is U sub n. Then what would the number in front of it be? U sub,
N minus 1.
yes. Because it has to be one less than whatever that other one was. Now the one after it would be U sub n plus 1. Very good. Write those three down. Okay. Maybe you'll understand better then when I give you an official sequence. This is a typical test question. If U sub 1, by the way, probably the first term, was 5, we did start with 5. If U sub 1 was 5, then U sub n, which is any random term, is given by U sub n minus 1. Now I know this is getting all really confusing, but it's not that bad. U sub n is any random term. I don't know which, any term, is given by the term right in front of it, except we add 5 each time on this kind, right? That's what's happening, right? Because we add 5 every time. So then I put a plus 5 here. And that is a recursively defined sequence. So if I give you this, you have to know, oh, so you're saying the first term's 5. And you're saying that any random term is given by the term in front of it except you add 5. That's a really complicated way of saying add 5 every time. So what's after 5? 10. It's after that 15. It's after that 20. ... means keep going. Make sense? This is called a recursively defined sequence. Recursive means that it keeps on repeating. Or it keeps on recurring. Okay? The recursive sequence just keeps on going back to the little rule and just keeps on repeating itself. All right. So if this was the sequence defined by this rule, if I give you a different rule, you should be able to tell me what sequence it is. This is the first 4 terms of the sequence. This was U sub 1. Then, by the way, this must have been U sub 2, and this must have been U sub 3, and this must have been U sub 4. As soon as you know the first term, you can know which term you're on. So, test question. Test isn't for quite a while, but this will be a typical test question. If U sub 1 was 15, and U sub n is given by U sub n minus 1, that's a really complicated way of saying any random term is equal to the term in front of it plus 4, then can you tell me what the first 4 terms of the sequence are? In fact, just do the first 3. If you get the first 3, you get it. Only 2 terms, you can't tell if the kid gets it, because you can't tell if they're adding or multiplying to get it. But if you do 3 terms in a row, you know the kid's got it. So, would you write down the first 3 terms of this sequence? This is a recursively defined sequence. And I know some people get confused on that very first one, and it is 15. The first one is 15. It's the first term. You have to tell me the first term, or I don't know for sure which term I'm on. So that's the first term. So then what's the second term? 19. And then the third one? 23. Raise your hand if you had that one right. Cool. You get recursively defined sequences. Now, can you do it in reverse? If I gave you that, you'd have known, oh, he can't be multiplying by something because it's not common. Like, sure, you could have multiplied by 19 over 15 to get this first one to happen, but then that wouldn't actually give you 23 next if you multiplied by this weird decimal. So it's got to be added. And so it's got to be added. It's arithmetic. And so if it's arithmetic, to define the arithmetic sequence, can you write me one of these? Well, yeah, it is that. You would say, I want to start with the first term, and then you'd have to write this thing, which is the weirdest thing, but it's the same every single time. You're going to write this. Here, I'm going to circle the stuff you're going to write. Every one of your sequences will have that and that. It's called boilerplate. It's an old word for, like if you have a legal contract, in every single legal contract, you define the two parties. You have to say, this is a contract between this guy and that guy, or this company and that company. That's part of the thing you always do. You always define who the contract applies to. All right, so in every single math sequence we have, you'll have this. And it looks like mumbo jumbo to somebody who hasn't been taught what's going on. To you, I hope it means, oh, first term, any random term in front of that. But if that's over your head, and I get it, for some kids, they're just trying to pass math. And I don't know if you know this, but in the state of Minnesota, this is the highest math class by law that you have to take. But then they kind of get you on a technicality, because in Minnetonka, you have to take, at minimum, 3 years of math. So maybe this isn't your last math class, because in Minnetonka, you have to have 3 years of math before we'll let you have a diploma. So you may have gotten as high as you have to be in the state of Minnesota, but to graduate from this high school, you got to have 3 years of math. So if this is only your first year of math, then you got to have 2 more years of math. Anyway, my point is, this is one of those things you're going to have to know for to pass. To consider the state of Minnesota is you understand basic, important high school math. That little boilerplate thing will happen every single time. And then you just got to put in the first term here and what you go up by here. All right, so let's see if you really got that. 12 plus 3 is 15, plus 3 is 18, dot, dot, dot. Write me a recursively defined sequence. Write me the rule. I'm almost done. Stay with me. I know it's hard to concentrate after having been just at home chilling for 10 days. Actually, did you guys have 11 days? Something like that. If you don't even know how to start with U1. And I think you'd know to put 12. And then this mumbo jumbo part, if nothing else, just memorize it. U sub n, and I'm saying sub as in subscript. U sub n equals U sub n minus 1. And since I'm adding 3 each time, I put a plus 3 here. Raise your hand if you had that one right. Cool. Now, there's always the little complicated thing come in at the end, and there's just one more little thing I have to add. I'm not sure whether we're going to require this on the test or not, but I can tell you we do in honors, and I want you to know it. And even if you're not in honors, you can understand this. N is greater or equal to 2. Now that is a little thing called the domain. And again, it's hard to understand, it's easy to do. What I mean by easy to do is you just memorize that you always have to end with this little n statement, and it'll always be 1 bigger than this. What it means is that this formula only works to predict the second term of a sequence. This formula can't tell you what to start with. Like I said, the starting term is super important. This formula, even though it's really cool, won't work unless you have the first term. It can't be used to predict the first term. Only the second and the third and the fourth and the fifth and the sixth. So you just slap on a little n is greater than or equal to 2 on every sequence to prove that you understand there's something called a domain. Again, I don't know. I'm being honest. I haven't looked at the test yet whether we're going to require that because it's complicated. But it's not that complicated. It's literally that every single time. Just like it's this every single time and that every single time. You see how those are all exactly the same? They're going to be exactly the same for the whole rest of the unit. Like I said, they're all going to be exactly the same. So if I say 2 times 3 is 6 times 3 is 18, I said it was always going to be the same. And n is greater than or equal to, who's got a short-term memory? 2. It only works for the second term or longer because you can't predict the first term. You don't know where you're going to start. But in this sequence, I started with 2. So then I just put the 2 here. And then what did I go up by? It did not add 3 every time, but it multiplied by 3. So do you get if you put something in parentheses, that implies that you're supposed to multiply by it? If you didn't know that, that's true. If you put that in parentheses, that means times 3. It's obviously different than if I put a plus 3. All right, we're done. We learned everything that you have to know. So now I'm going to give you one of each kind of test question. Here's one kind of test question. We started with 14, and then we add 10 each time. Can you write the equation for that? Try it. And then we'll go in reverse where I'll give you the equation and see if you can write the first feature. Kyle, what's U1?
U1, it's 14.
Good. Kyle, have you memorized that thing that's always going to come next?
Yeah, so it's UN minus 1. No, UN equals UN minus 1.
There you go. I knew you had all the pieces. Yep. UN equals UN minus 1. And since it's adding 10 each time, you put plus 10. How about the little ending that we're not sure if you're going to have, unless it's honors you have to have it, but here maybe not?
So n is greater than or equal to 2.
Perfect. There you go. Okay. How about if I go the other way? U1 equals negative 12. Don't let the fact we started at a negative freak you out. UN equals UN minus 1 times 2. Well, so what? That's an equation. So what can you make out of the equation? You can make the first 3 terms of the sequence. Well, you can make a million terms if you want. Try this one. It's the last one. Stay with me. Literally. You can do this. We're ready to move on. And do your homework, and you get a bunch of more time to work. And be a normal kid again. Well, it starts with negative 12. I do get how sometimes people feel like that's too easy, but nope. We told you the first term. It's right there. And then he times by 2, which would be negative 24. I just doubled it. And then I'm going to times by 2 again. And that's negative 48, I think. Anybody have negative 48 at the end? Yay, I'm not losing my mind. Good. This part's the recursive equation. This part is the first 3 terms of the sequence. All right, so where we're going from here, like tomorrow, what I teach you is I give you this equation and then I say, what's U sub 38? Do you really want to sit there and times by 2 38 times? Probably not. So there's an equation for that. That'll figure that out. And then here's another thing that we do. If I give you this equation, 2, 4, 6, 8, 10, these are the even numbers, obviously, right? What's the sum of the first 12 terms? It sounds like a bunch of busy work, like you just have to figure out all the 12 terms and then add them all up. But there's an equation that does it. So that's what we're doing tomorrow and the next day. Is how to find the 38th term without having to do all the other terms in front of it, and how to add up a whole bunch. And this is called a series. That's the sum of the series. We're going to do that on Friday. All right. There's the big picture. Now let's start your homework. It's a Schoology quiz. Would you please find it and open it? And I will start it with you because my dad always said if you started halfway done. So it says UN equals 20. And then UN equals UN minus 1, but then I walked away from my problem. Can you tell me what it says after that? Is it like times 2 or plus 3 or what does it say? Plus 6? All right, cool. What does it want? First 3 terms probably? First 4 terms, okay. Don't forget that the first term is 20. You don't have to do anything to get the first term. And then the next one is, well, add 6, so it's 26. And then the next term is add 6 again, 32, and then add 6 again. I think we're at 38. Did I do those right? I think so. That's all I got to do. Remember when you type in Schoology answers in, we have a few rules. Never use spaces. Unless it specifically tells you to, never use spaces. So don't put a space after the commas. All right. Would you read me problem number 2, Mr. Osberg?
U1 equals 47, UN equals UN minus 1 minus 3.
Awesome. What does it want?
The first 4 terms.
First 4 terms. All right, that's going to be super easy. 47 is the first term, and then you just keep subtracting 3. Easy peasy. Let's go on to problem 3. Kai, would you read me problem 3? Oh, crap, it's another one of those. Too easy. Let's move on. It's multiply? It's still that. See, you just have to multiply by whatever the number is. That'll be too easy. So let's move to the kind where we got to write an equation. Can you find me the first one where it's write an equation? Number 4. What is the sequence they give you, the series of numbers? Do you agree it seems like they're just adding something each time? And you can get that by doing this minus this. 6 minus 2 is 4. It seems like they're adding 4 each time. I double check it, and yep, they're adding 4 each time. Now, they could have asked you, is it arithmetic or geometric? Did they ask that or not? Okay. They could have asked you what the common difference was, and you'd have to say 4, but I don't think they ask you that yet. I think that's tomorrow. Taught you that ahead of time. But what they do ask you is to write an equation. So you start with U, and you don't have to make a subscript because you can't. So if you just write U1, that means U sub 1. So as you're typing your answer, I think they want an equation, right?
Yeah, they want the subscripts in parentheses.
But because we knew that it is such a pain, we took out the parenthesis requirement. So I know it says that, and if you put the parentheses, it'll mark it right. But the teacher also went through that made this quiz and took out the parenthesis requirement. So you can just write U1 and it will work. U1 equals 2. No spaces, just that. And then the next thing is U, and again, it'd be a pain in the butt to have to put these all in parentheses to represent that they're subscripts. So they just UN minus, or wait, UN equals UN minus 1. We'll all know that those mean subscripts. And then, is this times something? No, it's add something, so I just put plus 2. Isn't it? Oh, you're right. Thank you. Thank you. I felt like something was wrong and I couldn't figure out what. It is adding 4 every time. I saw this 2 here and this 2 here, and I was overloaded with 2s. Thought it had to be 2. No, it's what you add each time, which is 4. You are correct. All right. Yes.
For this Schoology quizzes, I could do like uppercase or lowercase too.
Excellent question. I am 98% sure that, and I'm so sure that I'm willing to go back and type in the answers if I'm wrong. You can use upper or lower case. So just use lower case to be like, I don't think that Schoology can tell the difference. Do you think that it can? What's your gut?
I'm not sure.
Yeah, it's fair. You asked the question, so I'm not sure either. But if it turns out I'm wrong, I'll type them in with uppercase or lowercase, whichever. Okay? So you can use either one. Yes?
I know you said like that you can teach like the find the value for the form and you get like U30 sort of thing.
Yeah, let's say you wanted U sub 30.
That is one of the questions.
Okay,
Number 7 is
well, there is a way. Right now, I'm not supposed to tell you the formula yet.
that. Okay.
And it will take a long time to teach that. So for right now, you just have to do all of the terms. Just it takes a while. Use the calculator, do, and then you get the 30th term. I hear you. It's a little bit of a pain, but the lesson's already been 38 minutes long, so I, should probably wrap it up. So this one is meant to just have to grind it out and do it a whole bunch of times. I'd use a calculator totally. Just go plus 4, plus 4, plus 4, plus 4, plus 4. All right. And that's all I got for you for today.